Draw formulae for the first 5 members of each homologous series beginning with the compounds. Okay, and we have compounds A, B and C. Now do you remember what exactly is homologous series? Yes, actually the homologous series is actually a set of compounds or a series of compounds which have same functional groups, exactly same functional group, but which differ from each other only by CH2 groups. So the only difference is you would simply have CH2 groups added, that's it, or CH2 n times. Successive members differ only by one CH2 group, or if you take any 2 members, they will be differing by CH2 n times, means CH2 whole twice, CH2 whole thrice, something of that kind. If this is vague, well, let me offer you something more consistent. First 5 members of A, now I have carboxylic acid. What has been given to me is formic acid, HCOOH, also called as methanoic acid. How do I get the second acid? I add one CH2. I get HCH2 COOH. This is acetic acid or ethanoic acid. Wow. And then this is HCH2. Now I add one more CH2. Propanoic acid. Old common name is propionic acid, latest name is propanoic acid. And then H1, 2, let me add one more. Achha, that is such a stupid thing. You keep on adding CH2 groups. It's not stupid. It's actually the method for obtaining the homologous series. Simply HCOOH, the first member. We insert one CH2. Then we have one more CH2, one more CH2 like this. We keep on getting more and more acids. One more. And what is this? This is pentanoic acid. So, methanoic, ethanoic, propanoic, butanoic acid and pentanoic acid. These are the first 5 members of homologous series of carboxylic acids. Similarly in B and C, if you see, in B you have a ketone, acetone, the smallest ketone, and in C you have ethene, the smallest alkene. Can you write down their homologous series by inserting more and more CH2 groups? I guess we can. Shall we? Let's do that. Well, this was the name, this was the carboxylic acid series, the names. It's a very regular theory, I'm just presenting it to you. This is acetone. Now, if I add one more CH2 group, I'll start getting different members. Acetone also is sometimes called propanone by 1, 2, 3. The carbon chain contains 3 carbons, so propanone. 1, 2, 3, 4, butanone, and ketone appears on number 2, so butane 2-one. Similarly, you have pentane 2-one. What I'm doing, I'm just adding CH2 groups here. Similarly, just because we were afraid of making this too long, so we have just added one more CH2 here, one more CH2 here. But overall, these have been the groups, and these are the ketones, as simple as this. Ethene, the first member. You add one CH2, like you had this ethene, HCH, 2 Now add HCH2. Now this HCH2 is nothing but CH3. This CH3 which you see here is nothing but this thing. Okay. Now you have one CH3. Now we add one more CH2. Then one more CH2. Then one more CH2. Keep on adding more and more CH2s and you keep on getting more and more members of the homologous series. It's as simple as this.